house. Just give us a little bit of history and how you got into weather.
A good question, and it was quite accidental. My background is physics. I went to Penn State University. In my early career, I did work for DOE. I was interested in working on renewable energies. I did some work on solar energy development. Worked on the Barstow plant out in California. Had the interesting experience when Ronald Reagan was elected president. He decided fossil fuels were great, and he zeroed out the budget for renewable energy development. And so I transferred my physics degree into designing sonar systems that went on guided missile submarines. So I like to say I went from renewable energy to mass destruction in about 2 weeks, showing the flexibility of a physics degree.
Nice.
And I was not involved in weather at all. I got pulled into it quite by accident. There was an article in the Washington Post in 1989, and it talked about a little boy that was struck and killed by lightning standing at second base on a Little League field. And the gist of the story was this was a tragedy, act of God. If you're going to play baseball in the summertime, these things happen. And as a physicist, it occurred to me that was a bad answer. The right answer was there was some way that there was a warning device or technology on that field. So the little boy wasn't standing, he could be struck. And that just got me into looking at what was available, and there wasn't anything. In 1989 and 1990, basically, unless you were going to drag a portable weather station out there, you were just going to wait for the sound of thunder and hope. And it got me thinking about what could be done. And I did some conceptual design work and decided that something could actually be built that could be portable and affordable and used by a Little League coach. And that led to the design and development of the SkyScan product, which was introduced in 1995. It was really the first practical self-contained portable storm detector, and that it actually worked. It was designed really for the youth sports and those kinds of applications. It only had a 40-mile detection range. It actually was only good for about 20 miles, but it was reliable enough to serve that purpose. It was my introduction into how fast technology can be made obsolete by the failure of the company running it. By the time the first shipments of SkyScan arrived from China, the SkyScan marketing company had already gone out of business. And so the manufacturer of the product was taken over by the Chinese, and it is still made today. You can buy it on the internet, which just shows really how good a basic design it was for the time. But it got me into weather. I had not really thought about it until then, and once I got into it from that experience and started having interactions with people that were using the technology, but most interestingly, I really got fascinated by thunderstorms. I became a de facto storm chaser because the things I needed to know to design the SkyScan product weren't in textbooks, quite literally. So I realized very quickly that what you could get from the library didn't help you if you wanted to build a device that actually would help people. And so I went out and started to teach myself what was actually going on. And that got me into this. I've been fascinated by it since then. I've been fascinated by, the huge disconnect between people's perceptions of things like storms and what Mother Nature is actually doing. So it's been a very interesting journey connecting the physics to what's really going on, to what the average person perceives is going on. And it got me very interested in actually producing technology that could make a difference, that actually go out in the world and do things like, keeping kids safe on Little League fields. Interestingly, as I got deeper into the design, and you get past that kind of an obvious need, protecting on a Little League field is nice, but I realized that there were really huge needs in all parts of our society, in schools and industry, that really demanded a kind of practicality that simply hadn't been done. It hadn't been executed. And it hadn't been executed because Mother Nature was very subtle, as she usually is, and it took a long time to figure out what she was doing and to take that information and knowledge and begin to roll it back into products. taking all the things that I'd learned with the Skyscan and having gotten fascinated with understanding thunderstorms and being able to make them understandable to people, that led me into the design of the Thunderbolt product. The Thunderbolt was introduced in 2003. It's probably still the primary handheld storm detection product used around the world because it's the best thing out there. It works. The thing that Thunderbolt did that the Skyscan didn't is that it actually was able to accumulate a small stream of data about a storm and build a model. And instead of just giving you a light stack that goes off when something happens, it accumulates data, tells you there's a storm out there, plots its relative motion to you, and takes that kind of information and turns it into an ETA. It turns it into time warning for people. Because one of the things that I learned in talking to people that were trying to use storm detection technology, distance didn't really do anything for them. They needed to know how much time they had at a particular spot until that spot was at risk. And so that led me into not only taking the physics of thunderstorms and trying to understand them and make my craft of detecting them better, but also providing that interface with people that made that information usable in real time. Ultimately, the name of the game that got me involved is making a difference. Data is data, that's nice, but saving lives, letting people make decisions that make a difference is really what it's all about from my standpoint.
Sure.
The Nimbus technology really is my third generation design. It's taking the 25 years of knowledge that I've accumulated and understanding that you really needed a much better mousetrap to catch Mother Nature in doing what she was doing. Because I wanted to go beyond just little bits of data coming in and little bits of data going out into a really sophisticated device that was seeing things that no one had really seen and tabulated before. Looking at data streams that are constantly coming out of storms, but that nobody's capturing. They're simply not being looked at by any of the existing other technology sources that we use today.
Sure.
And I think really that's what Nimbus is going to do. It's capturing and being able to access in real time a lot of data that simply isn't there in any source that you guys are used to looking at. And I believe it's also the way that we're finally going to be able to get a handle on doing things like anticipating, detecting tornadoes. The Nimbus is designed to look at what's going on in a thunderstorm and capture that complexity and in real time, because it's got enough computing power and data collection power behind it. And I think it's going to let us take a really big step forward in being able to provide warning about serious things that happen very quickly right now, that happen really too quickly for the existing system to react and pass warning downstream.